Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. Today we're going to use a deck of cards to get to know compound events and probability models. Before we get started, let's get to know some important vocabulary. An action in probability is doing something, dealing a card, spinning a spinner, rolling a dice, picking a random object. An event is an action with a specific desired outcome. So drawing a red card, spinning a 2 on a spinner, rolling an even number, choosing a red object. Okay, so again, an action is just describing what you're doing. That becomes an event when you look for a specific outcome. A simple event is when you are only doing one action. And these are all examples of simple events. A compound event, much like compound words are two words put together, race, car, basketball. A compound event is when two or more events are put together. I'm using the word action here because I think that it helps us to think about doing something physically twice. But that action might be the same thing. So it might be deal a card, deal another card. It doesn't have to be different actions. Examples are spinning a 2 on a spinner and dealing a red card. Or rolling 2 6s in a row on dice. Or in a deck of cards, dealing a red card and then dealing a black card. When dealing with compound events, we have independent events or dependent events. With a deck of cards, an independent event is when the outcome of the first event has no effect on the outcome of the second event. A dependent event is when the deck of cards changes after the first event occurs. An independent event with a deck of cards is when you replace the first card you choose. Let's take a look. What are the chances of us getting 2 black cards in a row when we replace the first card? We got our first black card. We're going to replace it. What's the chance of getting another black card? Well, it's still 26 out of 52. And it's red. There's an equal chance of getting a black and red card. We got it on the first draw, but not the second. The probability of getting a black and a black card when you replace them is 1/2, because 26 out of 52 cards are black, times 1/2. Because we replaced that first card, so there's still 26 out of 52 cards that are black. The chance of us getting 2 black cards in a row while replacing the first card is 25%. A dependent event is when the result of the first event changes the total outcomes of the second event. In the case of a deck of cards, it changes the total outcomes from 52 to 51. In this case, we're going to draw a card, and it's red. So the probability of getting a red card out of the whole deck of cards is 26 out of 52. We do not replace that red card. Now there are 51 cards in the deck and still 26 black cards. So the chance of me getting a black card now is 26 out of 51. And I did not get it. But I was more likely to get a black card than a red card. The probability of getting a black card when the first card I draw is red and I don't replace that first card is slightly greater than 25%. Now let's assume the first card I get is black and we're not going to replace it. I have a 1/2 chance of getting a black card when there's 52 cards in the deck and 26 black cards. Now, the likelihood that the next card I draw is black has decreased in both the number of black cards and the size of the deck. So now there are 25 black cards in the deck and there are 51 total cards in the deck. So the likelihood that the next card I draw is black is slightly less than 25%. 25% of 102 is 25.5. So 25 out of 102 is slightly less than 25%. That's a quick look at compound events using a deck of cards. Now let's look at a probability model using a deck of cards. There are two parts to a probability model. A probability model must take all the possible outcomes and categorize them. You could list all the possible outcomes to cover them all, or you can put them into groups. The other component of a probability model is that the sum of the probabilities has to equal 1 in fraction or decimal form, or in percent form it needs to equal 100%. Let's look at an example and a non-example. Let's break the deck of cards into red cards and then spades and clubs. This covers all the possible outcomes in the deck. As a percent, that's 50% plus 25% plus 25% is 100%. So this probability model works. This is an example. Let's look at a non-example. Okay, so we have all the black number cards, all the black face cards, and the black aces. We have all the red cards. We counted the red aces twice. So our probability model does not work because this will not add up to 1. 4 plus 26 is 30. Oop, I found a mistake. I only did half of the black card, so I need to double this. That's easy though, because 9 times 2 is 18. Double everything here. So, see? Everyone makes mistakes and that's okay. It's a learning moment. We can just double it all because it's proportional. We have 54 out of 52 because we counted the red ace cards twice. So this probability model does not work. Thanks again for watching another Muddy Math video where we take middle school math concepts that are a little muddy and clear them up. Don't forget to give this video a like and hit that subscribe button. Catch you next time.